Hello guys, this is Ashutosh Academy and today we are going to start with a new topic here that will be work energy and power. Let's understand what all we have to study in this chapter. The first thing that we need to study here is work done. Let's understand what is work done. Okay, the first topic here is work done. So work can be done by two kind of forces. Either the force will be a constant force or it can be variable. So the as you all know that the work done is defined by the formula F vector dot dr vector, and the vectors are taken to be the dot product here. So obviously we'll have to integrate here, and if the force is variable then the force remains inside the integration, and if it's a constant that is it can be any number, then it will come out of this integration and then we can integrate dr accordingly. Second that we have to study here is concept of power. Third thing that we'll cover in this topic will be the work energy theorem. Work energy theorem. So later on I'll be discussing about this theorem. This theorem works on two kind of things. First is it can work on a system of particles, or it can work on a single particle. So work energy theorem, both of the categories have different work energy theorems. Next is your energy. Let's discuss about energy now. The fourth thing is our energy. Energy is, obviously you might be knowing by now that energy is of two types. One is potential energy and another one is kinetic energy. Kinetic energy is due to the motion of the particle, and this is due to certain height of the particle. Now potential energy can further be divided into two subcategories. First is gravitational potential energy, and another one will be elastic potential energy. These are the two kinds of potential energy that I'll be discussing in my upcoming videos, so keep looking for my videos. And next what we have here is the last topic, that will be motion in vertical circle. Now let's start with the first topic here. Let me delete this. Okay, let's start with the first topic, and it is the work done. Okay, let me choose a pencil here, and okay, so we will be discussing work done. Okay, let's see a diagram here. Suppose this is your x-axis and this is your y-axis, and a particle is present here with its this is your origin here. Okay, this is your origin. Okay, so this vector will be the position vector of the particle. Let it be r1. This is the point P. So there's a particle which is present here at point P, whose position vector from origin is r1 vector. Okay, now suppose this particle moves from here and by following some kind of path, and it reaches this point. This is point P2, and this point P2 will have its position vector as r2 vector. So now obviously the particle has moved through this distance and reached this point. Obviously there will be some kind of force which must be acting on the particle to move that particle from one point to another. So this force can be of two types. It can be either variable or a constant force. So let's consider it to be a force which is variable, or depending on the situation, whatever we want, or the question says either it is variable or it can be constant. So let's go deep inside this diagram and see for a small portion of the path. If I zoom in here, what we will see here will be that this path is some kind of like this. When if you zoom in more, you'll see that this path is like this. So for we can name it as A point and B point. So what happens here between these 2 points A and B is that this is really very small distance. Let this distance be dr. Again, we'll have to consider it vector. Okay, so dr vector acts here, and now what we'll see here is this force which was acting on this particle. What should be the magnitude of that force? What should either should it be a variable or a constant? We'll look at it. If the force is some kind of variable, it must be changing. So if it is for a small distance, obviously the force should be constant because it's a linear motion in this direction. So for a small distance travel, we can consider force constant. That is, it may be it may be it did not get maybe the force did not get time to change, or if it changed, then it is very negligible. So that's why we are considering it to be constant force. So let the direction of the force be anywhere. I'm taking it here randomly. This is the force vector. And obviously by now you'll be knowing about the triangle laws of vectors. If there is a vector r1 vector, there's another vector which is r2 vector here. So the net, if you follow the triangle rule, will be this vector. Suppose this vector is x vector. So this vector plus this vector will give you the resultant vector. So what should be the value of x vector? We'll see r1 vector when added to, you can see the head to tail must be touching of the two vectors, will be equal to r2 vector. So we can say that x vector is equal to r2 vector minus r1 vector. So till now you've studied this. Now we'll be discussing about the work done force. So work done, that is a scalar quantity because it's a dot product, and whenever you take dot product products of two vectors, it will be scalar quantity. So work done for this small movement from A to B will be really small work done. That will be from point A to point B, and that work done, I'm considering it to be very small. That's why I'm writing it as dw, which will be equal to the force vector, because this force is now constant here, dot dr. The original formula for the work done is f vector dot dr vector. Now from here we can say that there should be an integration. Why? Because we have to add all the small parts here, and then we'll reach to this final path which is your x vector here. So we'll be integrating all the small parts here, and then we'll arrive at the final formula. So it says that we have to start from initial point, that is r1 vector, and we have to go till r2 vector. We'll say that the integration limit starts from r1 vector and goes till r2 vector. This will be your original work done, which will be followed here. Okay, so moving on, now let me write it again what this formula is, and then we'll take the cases here. So work done will be equal to integration of this small work done, which will be equal to from point 1 to 2, these are again vectors only, and then you have f dot dr vector. This is your original formula for work done. Okay, So what we have to do now is we will see to it that whether the force is constant or it is variable. If it's variable, then it will remain inside this integration, and if it's a constant, we'll take it out. Let's consider the case 1, that is keeping this force to be constant. And if this force is constant, what the formula will come out will be F vector dot integration of dr vector from r1 vector till r2 vector. So integration of dr vector will be r vector, and when you'll put the limits r2 and r1, you will get F vector dot r2 vector minus r1 vector. This will be your final work done formula. No need to remember this, because you can derive directly from this formula F dot dr from first point to any, and from the initial to ending point. Okay, now let's open this bracket. Okay, so work done will be F vector dot, what is this, r2 minus r1, that is x vector that I considered above here, this x vector from the triangle law. Okay, so r2 minus r1 is your x vector. So what we can say here is this into x vector. It can also be written as F vector mod x vector mod cos of theta. Now what is this? These are magnitude of the force vector and magnitude of the this displacement vector, and theta is the angle between the two, force and displacement. So if you consider the original diagram above, you'll see that displacement was in this direction, force was here, dx, that is x vector, was here, and theta is here. So this is the work done for this. Now depending on the situations, you will see there are various cases that you can draw from here. Suppose you have theta to be 0, theta can be either 90 degree, theta can be 180 degree, and there are another two cases that theta is acute angle, that is starting from 0 and going till 90 degree, and it can also lie between 90 degree to 180 degree, that is obtuse angle. This is acute and this one is obtuse. We'll see for all of the cases. The first case, when you put theta here to be 0, so cos 0 is sine 90, that is 1, then here the work done will be F into x, just the magnitudes. Okay, remember these are not vectors, these are just the magnitudes. And what should be the diagram for this? Simple. The diagram I'll just draw for the one part, the rest you can draw yourself. This is your r1 vector, r2 vector, this is your displacement x, and the force and displacement has 0 degree between the two, that means force is acting in this direction. So you have got work done is okay. In case of 90 degree, that means the force, if this is your original diagram from r1 to r2 and this is your x displacement vector, then the force will be acting in perpendicular direction, 90 degrees. So if you put 90 degree here, cos 90 will be sine 0. So that means work done in this case will be 0. Okay, moving on to another case. That is this one, when it is 180 degree. So if it is 180 degree, simple diagram, that is this is your x vector in this direction. Okay, but the force is acting in the opposite direction. So obviously work done will be fx into -1, that is cos 180 is -1, so minus fx. So you can go accordingly. Now let's consider another case, that is acute angle. Whenever you are taking theta to be acute angle, cos theta will always be positive. That means our work done will be positive. In this case, when the theta is between 90 to 180, then your cos theta will be negative in this case, and the work done will always be negative. So you can have the diagrams here. Okay, remember the path which is followed by the particle is like this only. This is your resultant. That's important here. It can go from point 1 to point 2 by any path, but we'll be considering the resultant path always. So r1, r2, r1, r2, this is x and this is also x vector, and in this case the force will make an acute angle. This is theta, that should be 90, should be less than 90 and greater than 0. Here in this case the force will be obtuse, that will be here, more than 90 and less than 180 degrees. So thanks for watching, and please watch my other videos. In the next video we'll be discussing about the problems based on this